Welcome to Mickey Study Circle channel. In this video, we shall see how to do the manual drafting of the orthographic projection of solids. In this problem statement, we have a hexahedron of 30 sides, which is resting on one of its corners on the horizontal plane, that is HP, such that one of its solid diagonals is perpendicular to the vertical plane, that is VP. So we need to draw the projection of the solid. So before we proceed towards drafting, let us understand few concepts here. So the first concept is it is a hexahedron. So whenever we tell it is a hexahedron, we need to understand that all the edges of this particular polygon, they measure the same. So that is the base edge and the axis, all the parameters, they are identical. And next thing is the resting condition. So it is resting in such a way that it is lying on one of its corners on the HP. And the next concept is with respect to the VP, one of its solid diagonal is perpendicular to the vertical plane. So let us understand what is solid diagonal. So just consider a cube, which is also a hexahedron, as shown here. So the top face of the cube is annotated as A, B, C, D, while the bottom face of the cube is annotated as A1, B1, C1 and D1. So here we have got the two faces, that is the top face and the bottom face, whereas C1C, C1B1, C1D1 are the hidden edges. So now we'll consider what is the concept of solid diagonal. So whenever I'm drawing a diagonal from C to A1, that is the corner points which are opposite on the opposite faces. So whenever I'm joining them, it becomes the solid diagonal. And similarly, B to D1, it is also called as the solid diagonal. So here we need to understand that one of the solid diagonal is held perpendicular to the vertical plane, that is in the third position. Also, here there is no clue given about the condition of the horizontal plane, that is the parameter with respect to the horizontal plane is not detailed in the problem statement. But however, we do know that whenever we are considering to keep one of those solid diagonals perpendicular to the vertical plane, we do require the true length of this solid diagonal. And that true length of the solid diagonal is obtained when it is kept parallel to the horizontal plane. Only then its true length is obtained. So from the projection of lines, we do know that whenever a line is kept parallel to the horizontal plane or the vertical plane, only then we do get the true length of the line in any of the planes, that is VP or HP. So we shall apply that concept here. So in the second position, we are going to present the solid diagonal parallel to the horizontal plane so that we get the true length of the solid diagonal, which is later on utilized to construct the third position, that is perpendicular to the vertical plane. So with this input, let us proceed towards constructing the first position, that is the hexahedron resting on one of its corners. So we'll begin the drafting by drawing the XY line. So let us first draw the XY line. Let us annotate this line as the reference line, that is X and Y, and also the planes as VP and HP. So now we'll proceed towards constructing the hexahedron, that is nothing but a cube which is resting on one of its corners. So for that, let me just consider any one line, and from that line I'm going to draw a 45-degree line so that I'm going to get the cube resting on one of its corners, and the edge length measures 30 mm. So if I'm just drawing a line passing through all this grid boxes through the diagonal, so it is confirmed it is a 45-degree line. So let me just consider only the dimension, that is 3 mm. So this is the first step. So this is one edge that I'm going to draw, and the next edge, let me use the set square again and then draw a line passing through the corners of these grid lines, and the dimension will be equal to 3 mm. So you can just see that this is the second position, the second edge. Next, let me continue the same. So from this line, I'm going to draw a line of 3 centimeter length passing exactly through the corners of these boxes. So this is 3 centimeters again, and next we'll just complete this opposite edge. So this is the square, which is the top view of the hexahedron resting on one of its corners. Now we shall just represent the diagonals of this particular square. So this is one vertical diagonal, and this is the next horizontal diagonal. So now let me draw the projection lines. So from this corner and also from this corner, next projection line from this particular corner. So now let me do the annotation. So let me tell that it is resting on one of its corners A1, which is the bottom face, and the top face is A. And next is the corner B, which is B1. And next is the corner C, C1. And next corner is D and D1. So O is the axis point on the top face of the hexahedron, while O1 is the axis point at the bottom face of the hexahedron. So let me just indicate the direction of the projection line upwards. So now after this position is completed, we'll proceed towards drawing the front view of the hexahedron. So the front view also, it will be measuring 3 mm because it is a hexahedron. So I can just do that by drawing a 3 centimeter line. So this is the first outer edge, the second outer edge, and let me draw the base of the hexahedron by joining this extreme endpoints of the projection lines. And next, the top face of the hexahedron, and also one more face. This is the edge of the hexahedron, which is seen. The axis is overlapped by this edge. So maybe once we do the annotation, we'll get an idea. So this is A1 dash, while this is A dash. And next this is B1 dash, which is visible, and D1 dash, which is not visible. Similarly, this is B dash and D dash. And O1 dash is also not visible, so it is exactly behind this edge. So let me just indicate them inside the bracket. And similarly, this is C1 dash followed by C dash. So this completes the initial position wherein it is the hexahedron resting on one of its corners, A1, and A is the corner on the top face of the hexahedron. So it looks like a square resting on one of its corners, whereas in the front view you can just see that there are two faces of the hexahedron which is seen, that is A dash, B dash, and then D1 dash and A dash, A1 dash. So this is the face, and the next face is C dash, B dash, and then C1 dash and B1 dash. So these two faces are seen in the front view. So now let us proceed towards drawing the solid diagonal. So the solid diagonal is, like it is from C dash to A1 dash. So this is the solid diagonal that I'm going to consider for the next two positions. So this is the solid diagonal, that is C dash to A1 dash. Now in the second position, I need to rotate this hexahedron in such a way that this solid diagonal, that is C dash A1 dash, becomes parallel to the horizontal plane so that I get the true length of this solid diagonal. So how do we do that? Let us make a small construction here. And the construction is, we'll just have to draw a perpendicular. So we'll just consider drawing a perpendicular, that is a 90-degree line passing through the corner C1 dash. So I'm just marking 91 degrees. So this is the reference line that I'm taken, that is the solid diagonal. And next I'll do this construction. So I'll just draw a perpendicular line passing through the corner C1 dash and intersecting the solid diagonal. So this is the construction that I've done. in order to check whether it is exactly 90 degrees, just do this and cross check it is 90 degrees. So this is the perpendicular that I've drawn. So let me call this point as R. So this C1R, C1 dash R that I'm doing here is the construction line. So this will be used for me to make this particular solid with its solid diagonal parallel to the horizontal plane. So let me see how that could be done. So first let us try to measure this construction line. So the construction line, let me take the measurement of that. So the construction line is measuring 2.5 mm. So that is 25 mm. So I'll transfer that 25 mm here. So I'm just making the line perpendicular to the reference line, that is C1 dash and R is put up here. And now I'm going to measure C dash to R. So that is somewhere between 1.3 1.8 mm. So I'll just transfer that. .8, and next is this part that is R to A1 dash. So this is somewhere between 3.3. So I'll just transfer that also. So now this is how we can transfer the lines by drawing the perpendicular lines. So 3.3 mm. So the total length is around 5 mm. Okay, so let me just check. So the solid diagonal is transferred in such a way that it is parallel to the HP. So that will be getting the true length of the solid diagonal in the top view. So we'll just do the annotation so that it will be clear. So this point was C1 dash, correct? And this point was R, and this is C dash, and this extreme point is A1 dash. So now if I join C1 to C dash, it is measuring 30 mm. So here also it will be equal to 30 mm. So it has been complete, and now I'll just transfer this C1 dash to A1 dash. So I'll just join this. This is C1 dash to A1 dash, and now I need to transfer this part, that is A1 dash to A dash. So for that I'll just keep the protractor here, and I know that this is a 90-degree line, so I'll just mark 90 degrees and then transfer the 3 mm line at this 90 degrees. So this is the 3 mm line that I've transferred at 90 degrees, and this point will be, or this corner will be A dash. So now I need to join C dash to A dash by a straight line which is measuring 90 degrees. So I'll just use the set square for this. So the set square is 90 degrees now. So I'll just transfer or just join C dash to A dash by a straight line. So this straight line is complete. So now I to join this, draft the line of this edge. So I'll just measure C dash to B1 dash and D1 dash. So it is exactly half of it. So I'll just keep that point here. Now let me use the set square again at 90 degrees and then transfer the length, that is the edge length. So now I'll complete the annotation. So this is C1 dash, A1 dash, A dash and C dash. So this part was B1 dash inside the bracket, D1 dash. Also this is O1 dash, and here it is B dash and D dash, and also it is O dash. So this completes the part wherein I've transferred the solid diagonal in the second position in such a way that it is held parallel to the horizontal plane, so that I'll be getting the exact uh, length of this solid diagonal in the top view of the second position. So now let me complete the top view. So let me draw the projection lines. So I'll take the first projection line from this corner C1, followed by the next projection lines from C dash, and projection lines from B1 dash and B dash. The next projections from A dash. And you can just see that A dash and B1 dash will be on the same projection line, and similarly C dash and B dash will also be on the same projection line. Now let me transfer the horizontal projection lines. So this is from A and A1, and next from D1 and D, and next from B and B1. So let me annotate the points first so that completion of the third position, that is the second position top view, becomes easy. So this point is A1, and from A1 to I have to proceed towards B1. So this point is B1 here, and this point is D1, and next I require the point C1. So C1 is here, so this is the point C1. And similarly, I told that the projection of A1 is also on this line D1 itself. So it is the corner A is here. So the corner A is here. So this is the projection line for both A and D. So this is the corner A, that is the top face. And next, the corner B is here. Next, the corner C is here, followed by the next corner, that is D, which is here. So now let me identify the farthest corner point. So the observer is looking from this direction, and for him the farthest corner point will be C1. So all the edges passing from C1 will be dotted. So let me just complete this view. So C1 to B1 will be dotted. That is the hidden line, which is represented by the broken lines or the dotted lines like this. And next, C1 to D1 will also be hidden. So I'll just transfer this. And C1 to C will also be dotted. So now this part is over. So now let me complete the other edges of the hexahedron, that is A1 to D1, followed by A1 to B1. So this edge is completed. So next point is from A1 to D, that is the top face. A1 to D is this. Next, from A to B, A to D is over, A to B is also over. Next, let us connect the edge BC, and next the edge CD. And now let me just connect the outer edges, that is B to B1. C to C1 is connected by the dotted line, as you can see. And next is A to A1. So this is also visible, so it is to be darkened. And next is from D to D1. So this is how we complete the second position of the hexahedron, wherein you can just see that the top face A, B, C, D is visible clearly, and this face, that is okay, so this corner is A, so this face D, D1, A, A1 is seen, then A, A1, B, B1 is seen. So the rest all are the hidden faces, which are represented by the dotted lines. And also one more thing that you can note here is the axis points, correct? So the axis point O1 is here, so this is also O1, and this is the point of O. So this small distance that we get to see is the axis line. So let me just complete that part by using the chain line. which is the axis line. So I'll be using the chain line to represent the axis from O to O1. So now you can just see that C to A1, whatever I'm getting here, C to A1, so that is the true length of the solid diagonal in the second position. So in the third position, I'll be utilizing this true length C to A1 and rotate this in such a way that it becomes perpendicular to the VP, that is the vertical plane, as given in the problem statement. And now you can just see that in the second part of the problem statement, it has been asked like find the inclination of the base of the hexahedron when its solid diagonal is parallel to the HP. So this is the solid diagonal and this is the base of the hexahedron, that is C1 dash to A1 dash, and it is inclined to the HP. So that angle, if you measure, that will be the solution for that part of the question. So it will be somewhere around 35 degrees. So that is the angle of inclination. So we can just show the angle of inclination as 35 degrees, which is the solution for 2B. So now this part is over. So now let us proceed towards constructing the third position, wherein we are going to rotate the hexahedron in such a way that its solid diagonal, that is C and A, CA1, is going to be perpendicular to the VP. So let us just measure the total length of the solid diagonal. So the total length of the solid diagonal is, like 50 mm, that is 5 centimeters. And I'm going to transfer that 5 centimeters in such a way that this corner C will go up. So let me proceed that. So you can just see that C1 to C, or rather from C to A, this particular dimension is around 3.5 mm, which is dotted. So I'll complete that part first. So until 3.5 centimeter it is dotted, and next from 3.5 to 5 mm it is a continuous line. So this part is over. So let me annotate this simultaneously so that we'll not have any confusions when we are doing the constructions. So this is the corner C and this is the corner A1. And now in order to complete the other part of the hexahedron, so this hexahedron has been rotated like this. So here I'll be having D and here I'll be having the corner B. In order to do that, I'll just measure the other distance and I'll be transferring it. So now we have finished transferring the hexahedron in such a way that its solid diagonal, that is CA1, is held perpendicular to the XY line. So you can just see that I've taken the hexahedron from the second position, rotated, first drawing CA1, and then I've taken the measurement of D and B from this point, and I've located the point D and B. So I've got the corner D and B here, and B to B1, D to D1, they're perpendicular, so I've measured that. And similarly, I've got the points A1 on this solid diagonal itself, and I've completed the construction of the hexahedron in such a way that the solid diagonal is held perpendicular to the XY line. So now I'll be completing the front view of this by drawing the corresponding projection lines. So let me draw the projection lines in the front view first. So this is the projection line from the corner A dash. And next the projections from B and D. And next the projections from C1, that is C dash and A1 dash, it will be on the same line. And next the projections from B1 and D1. So the corner C1 is on the XY line itself. So now let me take the projection lines from this. So I'll take the projection lines from A1, C1, C. So I'll just consider. So first point is C1, I get it on the XY line. And next the corner is C1. So I'll just proceed till here, which is the corner C1. And next I've got the corner A, which is also here. And next the corner A dash. So let me just annotate. So this is the corner C1 dash. And next I've got the corner C dash on this line. So this is the corner C dash. And also the corner A is also here. So this is A dash, and next the corner A1. So the corner A1 and C1 will be on the same line. So this is A1 dash. So this is A dash, C dash, C1 dash. So the other corners B and B1 will be on the same line. So let me just complete that. So from B and B1, so this is the point, this is the corner B1 and this corner is B dash. And next from D and D1, which is also on the same points of B. So this is D1 dash and this corner is D. So now for the observer, the corner C is the farthest point. So let me complete the base of the hexahedron. So C1 dash to B1 dash, I'll be joining this. And next similarly, C1 dash to D dash, D1 dash. So next D1 dash to A1 dash. And next A1 dash to B1 dash. This completes the bottom face of the hexahedron. And next let us take up the other face. So A dash to D dash. This is D prime or D dash. So let me join this. A dash to D dash. And next D dash to C dash. So it is hidden. So let me just represent that using the hidden edges, because C dash is the farthest corner point. Similarly, C to B will also be hidden. And next A to B. So C1 to C will also be hidden. So I'll just represent that by the hidden line. So this is the hidden line, and all the other outer edges. Let me just highlight that. So the outer edges, that is B1 to B, D1 to D, and A1 to A. So you can just see that A1 to A is visible, and this is the bottom face of the hexahedron, and these two faces are visible, and this bottom face of the hexahedron is completely visible. So with this we complete the problem, wherein we have got one of its solid diagonal, that is C1 to A1 perpendicular to the vertical plane. So this is how we do the drafting of the hexahedron, which is resting on one of its corners initially and having its solid diagonal perpendicular to the vertical plane. Thank you all for watching.